Hey everybody, this is going to be the learning target number 5 video for anybody in Enriched, okay, anybody that did the Enriched this chapter. If you were just in the regular, it's actually learning target number 2 on your learning target sheet. That really doesn't matter a ton this time. I just want to make sure you are clear that you do have to do it. So if you were not in Enriched, you should be on page, I believe it's 11. Page 11 right now is where this is. Okay. If you were a part of the Enriched, you're gonna have this first page, but you will not have the next page, page 12. So I posted it on Schoology, so you can print it from there, or you can just write it on a separate piece of paper. I don't really care. Okay. All right. So let's start working on this. I'm gonna try to keep this short. Now we covered this on Thursday, and we talked about this a lot. We talked about part plus part equals whole, part times part equals whole, and then when we're doing subtraction and division, we know the whole and one of the parts, and then division is the same way. We know the whole, we know one of the parts, we're trying to find the other part. So we talked about how this related to this, okay? Now, remember, when you're, any division problem is, right, make sure you're writing what I'm writing too. Dividend divided by divisor, okay? Okay? So the first number in any division problem you ever do is your dividend. Remember, dividend is the number being, whoops, that's an E, being divided. Okay? It's the number that's being divided. Now, there's another way to kind of remember that. You could say number being divided. Also, I said the number being grouped or being cut into pieces or sliced or whatever. It's the number you're taking, and you're saying, I want to take that and I want to divide it, okay? Or I want to cut it up, or I want to share it equally, or whatever the wording that is used. This number right here is your divisor. It's the number that is doing the dividing. All right. So basically, it's all about being able to identify what's being divided and what is doing the dividing, okay? And that can become tricky sometimes, but you really got to think about it. So here we go. Don't worry about what this says. I'm not really worried about that. Okay. Mariska has 2/3 pound, so she has less than 1 pound, so she has 2/3 of a pound of sunflower seeds. Each day, she feeds the cardinals in her yard 1/6 pound of seeds. Okay. For how many days will she be able to feed the cardinals? Okay. Now we've got to think. What's what here? When we can think in these terms right here, whole, part, and part. We have to determine which one of these numbers is the whole, which one is the part, and is the question asking for a part or is it asking for a whole? That's what we've got to figure out, and that's why we've really got to think, okay, what's being divided here? Is the 2/3 pound of sunflower seeds, is that what's being divided? Or is the 1/6 that she's going to use each day? Okay. Now, hopefully you're all thinking, oh, well, she's going to divide that 2/3 every day, and then she's going to divide that by the 1/6 because that's how much she's using every day. 2/3 is what she has in total. Okay. So, one thing I like to do, I'm going to think backwards here real quick. And you don't have to do this. You don't even have to write this. Just think with me. If I said to you that she gives let me do it differently. I'm going to make up a new problem. Let's say that I'm feeding my cardinals in my yard, and I give them 2 pounds each day. And let's say that I know that I'm going to feed them for 10 days. What would I do to figure out how many total pounds I'm going to need of sunflower seeds? Total pounds. By the way, this is pounds in case you were wondering. Okay? I think most of you would say, well, you do 2 times 10, right? And that's absolutely correct because think about it. The amount used each day is a part. The amount of days that you're doing it is a part. And we know that whenever we know the parts, then we better be trying to find the whole, which total pounds, right? So now to go back to this question, this is how much is being used each day, right there, right? This is what she's taking from, so the dividend, okay? So that's how you kind of break it down. Now from here, it's pretty easy. you guys all know the algorithm. Now, because these are already in fraction form, which means one number over another number, I know that this only has to be in one step. So that's going to be 2/3. Dividend stays the same. We know the division is just multiplication by the divisor's reciprocal. So that's multiplication by the reciprocal of the divisor right there. Now at this step we can check for cross simplifying. 2 and 1, nothing there. 3 and 6, do they have a factor other than 1? Yes, they have 3. They both share 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. And I know that's going to be 4 over 1 or 4. Okay, and there's your answer. So that makes sense, doesn't it? For how many days will she be able to feed the Cardinals? She's going to be able to feed them for 4 days. Right? I mean, think about it. If she's 1/6 is less than 2/3. So if you want to check it, now what you could do, you don't have to do this, but you could say, okay, well then if I'm gonna do this what I did over here, 4 days times 1/6, it had better give me 2/3. There's 4/6, divide 2. It better get me that whole, because again, if I know that this is a whole and I know this is a part, then I know the question is another part, the amount of days. Whereas what I did right here is I said, okay, that's a part, and we know that when we multiply parts, we're going to be given the whole. See how it works, how that's whole? Okay? You don't have to do all that work. You don't have to do this. All you had to do was this and this, and show the answer that way. That's all you have to do. But I just want to make sure everybody's aware of which one of these is the dividend. Okay? Here we go. At summer camp, the duration of a field hockey game is 3/4 of an hour. The camp counselors have set aside 6 hours for field hockey games. How many games can be played? So, once again, we're at the same process. You have to ask yourself, what's being divided? Okay? Now, like I said on Thursday before we had our long weekend, a lot of times we get in division problems, we are given the whole first, the dividend first. Okay? I mean, there's just a lot of times, like here, this is going to be dividend first. Okay? Don't ever start doing just that method, because it will be wrong. Okay? You will get it wrong. Just ask yourself, are we dividing the 6 hours that are set aside into 3/4 hour sections? Or are we taking the 3/4 and dividing it by 6? Hopefully you're all saying divide the 3/4, or divide the 6 hours that they set aside for field hockey, divided by the amount of an hour that it's going to be played for one game. And this should give us the games. This is a whole, this is a part, and the question is asking for another part. Now, how many steps should you show this in? You should show this one in 2 steps, because guess what? This is not in fraction form, both numbers. So the first step would be to leave it division. Then the second step would be to do the algorithm. 4/3. Okay. Again, we have a 6 and a 3 that they have a 3 in common, so that becomes 1, that becomes 2. And we learn that they are going to get 8 over 1, which is 8. They will be able to play 8 games in that 6 hour span, because each one is 3/4 of an hour. Okay, here, Turner has 6 pounds of pasta. Each time he makes dinner, he uses 3/4 of a pound of pasta. How many dinners can he make? So just ask yourself, what's being divided? The 6 pounds of pasta, is that being divided? Or is the 3/4 pounds of pasta? This is just what's doing the dividing. That's how much he uses each time. Okay, so this is just going to be 6 divided by 3/4. It's actually the exact same question as that one. I didn't even realize that. That's kind of funny. So again, I would need to see 2 steps, and I won't even show it because we already did the answer right there. He can make 8 dinners. It's the same problem. Okay? Last one here. Raphael took 4 pumpkin pies to a family gathering. If he divides each pie into 6 equal size slices, how many slices can he serve? Okay? So, what you're doing is, I mean, you could draw these out, but you just have to say what's being divided. Is the 4 pumpkin pies, or is the 6 equal slices? The problem would be 4 divided by 6. Or I'm sorry, it wouldn't be. This one would be just 4 times 6. This one's kind of weird. It's actually would be 4 divided by 1/6, because it's each piece is 1/6. regardless, this is, I would think, I honestly, this question, I remember from last year now that I'm reading it. This question, I probably wouldn't show with division, as I would use more just like mental math, I think. Because if you think about it, if you have those 4 pies and you cut each one into 6 pieces, whoops. So if I cut it here, I know those aren't even, but let's say they are. You'd have 6 slices there, 6 there, 6 there, 6 there. Obviously, that would mean 24 total. So that one's a little bit different, but let's just go on. Okay, go on to the next page. Okay. In January, Jane volunteered at a hospital for a total of 12 hours. She spent 4/5 of an hour at the hospital every time she volunteered. How many times did Jane volunteer? Again, just ask yourself, which of these is being divided? Is the total, remember, whole divided by part equals part. So when you're doing this, you're saying, okay, that must be my dividend because that's what's being divided, and I'm dividing it into 4/5 of an hour time frames. Now, make sure you're doing this in 2 steps because I got to put that in fraction form. So that would be 12 over 1 divided by 4 over 5. No math really happening there, just putting it in fraction form, improper fractions. Now I'm going to do the algorithm, 12 over 1 times 5 over 4. Let me rewrite that over here so we can all see it. Okay, 5 and 1, nothing I can cross simplify with. 4 and 12, they both share a 4. So I know that she must have spent 15 occasions. She spent that much time at the hospital. Okay, again, work here required. Obviously showing that the step, turning them into fraction form, and then showing the algorithm, and then getting your answer. Okay, I'm going to erase this a little bit just so that we can see up here. There we go. A recipe calls for 3/5 of a cup of flour. Okay, so that's how much the recipe calls for. Courtney wants to cut the recipe in half. How much flour will she need? Okay, so she wants to cut it in half. So think about this. What's being divided? Is the 3/5 of a cup being divided? Obviously, guys. And she's going to take that, and she's going to take it and divide it by 2. Okay? She's going to divide it by 2. Right? Isn't cutting it in half the same as dividing by 2? That's why if we're doing 2/3 divided by 2, if we do the algorithm, first of all, writing them as fractions, 2/3 times a half. Dividing by 2 is the same thing as multiplying by half. Okay, that's exactly what the algorithm says. Okay, so now we'll do this in 2 steps. There's 1, there's 2. First step would be to put them in fraction form, so that's going to be 3/5 divided by 2 over 1. Then step 2 would be the algorithm, 3/5 times 1/2. I look to cross simplify, there's nothing. I'm going to get 3/10. So that means that Courtney, since she's only making half of the recipe, she will only need 3/10 of flour. She won't need the full 3/5. Okay? Now, Helena wants to triple the recipe. How much flour will she need? Well, this one, again, a little slightly different. This is why you just can't get in the habit of constantly just dividing every time, because this really isn't division. This is saying that's how much it called for, the original recipe. She wants to triple it, which means times 3. Okay? So then I would just do 3/5 times 3 over 1. And that's it. Okay? So we would check for cross simplifying. There isn't any. That's going to be 9/5 or 1 and 4/5. So this would be how much Helena, or Helena, however you want to say it, that's how much she would need to make her recipe tripled. Okay? So can't just automatically think, oh, we've been doing division because that's what the learning target says. That must be what it is. No, it doesn't work that way. You need to think. Okay? All right? Let me move this up a little bit. There we go. Okay. Luke has 6 sheets of colored paper. He uses 4 sheets to make posters. He cuts the remaining paper into equal rectangles to make greeting cards. Each rectangle is 1/4 of a sheet of colored paper. How many greeting cards does Luke make? Now this one you got to do a little work because there's something in here that I like to refer as distractors. I see 3 numbers. And really, only one of them is even important. Now, what you got to realize is if he has 6 sheets and he has those 4, how many sheets does he have remaining? You should all be saying 2. And since he's cutting the remaining, doesn't that make the dividend 2? Right? And then he's taking those 2 left over that he's cutting up, that he's dividing up into 1/4 sections. So step number 1, put them in fraction form. 2 over 1 divided by 1/4. Step 2, go ahead and do the algorithm for division, which is division is just multiplication by the divisor's reciprocal. So this is going to be 4 over 1. And we know that he's going to be able to make 8 over 1, which is 8 greeting cards out of those 2 remaining pieces. So that one, we kind of took it a step further, right? I didn't just come out and say, oh, he has 2 pieces of paper. He wants to divide them into 1/4 sections, 1/4 size sections. Okay, it didn't say that. You had to do a little work. That's where they get a little more challenging, okay? A party-sized sub-sandwich is prepared for a team dinner. The sandwich is 5.5 feet long, is divided into half-foot pieces. How many pieces of sandwich are there? Again, I hope you guys are getting the picture here. What's being divided up? Is it the 1/2 or is it the 5.5? Obviously, it is the 5.5. And I always expect you to write the problem out. Now, remember, we're going to do this in 2 steps. First step would be putting them in fraction form. So we've got to go around the barn here. 2 times 5 is 10. Plus 1 would be 11 over 2. Do I need to do anything to 1/2? Nope, because it's already in fraction form. Now for step 2, I'm going to go ahead and do the algorithm. So dividend stays the same. Divide becomes multiply. 2 over 1. Check for cross simplifying. I see 2 and 2. Anytime you ever see the same number diagonal, you know they're automatically going to become 1 because they have a factor of 2, obviously. And we're going to get 11 over 1, which means if I have 5.5 foot long sub, and I want to cut it into 1/2 pieces, I'm going to be able to feed 11 people, or at least 11 people are going to get a 1/2 foot, a 6-inch sub. Okay. Number 5, four of my best friends are over at my house. I had 7/8 of pizza left over from last night. If I want to give my friends equal amounts of pizza, how much pizza will each friend get? Okay. So again, you just can't be a robot. You can't automatically just go ahead and do 4 divided by 7/8. First number divided by second number, even though it's like that there. It's like that on the one above that I already got rid of, but you guys get the point. It usually is just first divided by second. You can't think in those terms. What's being divided? Are my 4 friends being divided into groups, or is my 7/8 of my pizza left over being divided? Hopefully you're all saying 7/8 is being divided by my 4 friends. Okay? Now I'm going to do 2 steps. I'm going to put them in fraction form, so like that. And then step 2 would be doing the algorithm. So 7/8, divide becomes multiply. The reciprocal of 4 over 1 is 1 over 4. I look to cross simplify. I'm going to get 7/32. Now I know that 7 is a prime number. So the only factor that could even help me simplify here would be 7. And I know that 7 is not a factor of 32. So right there would be my answer. 7/32. Each friend's going to get 7/32. And if you wanted to check this, you could come over and say, I'm going to do my answer times my 4 friends. I'm going to see if that gets me back to what the amount of pizza I had originally. Okay? And if it's not, we've done something wrong. 28 over 32, they would both share a factor of 4. Here's my 7/8. Gets me back to my whole. So this is part times part equals whole. This over here is whole divided by part, and it gave me a part. Okay? Hopefully you're seeing how that's working. All right? So again, big thing, guys. Identify what is being divided, what is being cut up, sectioned up, grouped up. What are they actually taking and putting into groups? Okay, that's the whole point. Okay, and that's what makes this a little challenging. Okay, I know you know how to do this step. It's just setting it up, actually setting up the problem. All right? Good job, guys. See ya.